Ladies and gentlemen, I can't believe that I have been selected as this year's Best Research Award of International Research Awards on Neurology and Neurodisorders. When I was informed of my nomination, actually, I can't believe it. In fact, I believe that there are many outstanding scholars deserve this award. I just think I'm the lucky one. I'm so glad and feel very honored to give you a brief presentation here. My topic is the brain-inspired Memristive spiking neuron models. The main contents include three parts. Part 1. The MLIF spike neuron model. Part 2. The MIZH spike neuron model. Part 3. The FHN spike neuron model. The human body is a complex organism. The brain and the spinal cord are central parts of the nervous system. The brain is the most important and complicated part of all organs. It is composed of a large number of neurons. The neuron is a kind of highly specialized cell, which is the basic structure and functional unit in the nervous system. Neurons can receive, integrate, transmit, and output neuron signals in real time, and can realize the interaction and propagation of neuron signals between neurons. Such powerful neurons have attracted wide attention and researchers in various fields. To mimic the behavior patterns and functional mechanisms of neurons, academic scholars proposed a lot of artificial neuron models, such as the LIF spike neuron model, the FHN spike neuron model, and the IZH spike neuron model. They are all typical simplified neuron models based on the HH spike neuron model. The LIF spike neuron model consists of a differential equation with a few parameters. The FHN spike neuron model consists of two differential equations with three control parameters. The IZH spike neuron model consists of two differential equations with two control parameters. They can reproduce the firing processes and functional mechanisms of neurons. But there is a disadvantage. Their ion channel don't have the memory property. Therefore, we need to find an electronic device with memory function. The memristor is a non-volatile and non-linear electronic device. In fact, the pinched hysteresis of a memristor appeared as early as the arc discharge experiment in 1801. It was not known at that time it was a memristor until 1971, The Memristive was officially proposed and physically implemented in 2008. Subsequently, scholars in various fields have found that the Memristive phenomenon can be observed in organic matter, human skin, human white glass, and even plants. A single neuron is composed of a soma, dendrites, and an axon. The axon is a crucial part to propagate neural signals. It consists of lipid bilayers and ion channels. The lipid bilayer can be represented by a capacitor. The ion channel can be denoted by a resistor or a memristor. Therefore, the structure of the neural axon membrane can be physically simulated by parallel connection of a resistor and a capacitor, or a memristor and a capacitor. The LIF spike neural model can mimic the firing patterns and the information propagation of neurons. We replace the resistor in LIF spike neural model with a memristor, and the MLIF spike neural model can be achieved. When the different external stimuli are applied to these two models, they can generate the action potentials, but there is a difference between them. The MLIF spike neural model performs high firing frequency and good biology frequency adaptability. A memristor can be used as a synapse and realize the interaction and propagation between neurons. Not only that, the memristor can perform the integrating and the filtering functions of biological dendrites. Meanwhile, it can perform the integrating and the firing functions of biological somas. It means that the memristor can be used as the dendrite and the soma. And then the memristive neuron circuit is constructed. The simulating results show that this circuit can effectively complete the generation and the propagation of firing patterns. The narrow pulse current and the wide pulse current are applied to the MLIF spike neural model, and the two-spike action potential and the four-spike action potential are obtained. The two-spike action potential is the resting state of the MLIF spike neural model. The four-spike action potential is the firing state of the MLIF spike neural model. And then the Morse code of alphabets can be represented by action potentials. The simulating results show that the MLIF spike neural model can realize the generation and the recognition of the Morse code. The IZH spike neural model display spiking and bursting behaviors of neurons. We combine the Memristive with the IZH spike neural model, and the MIZH spike neural model is obtained. When external stimulus is applied to them, they can generate action potentials. And the MIZH spike neural model perform high firing frequency. The different external stimuli applied to the MIZH spike neural model, it can generate 23 firing patterns. We use 800 excitatory neurons and 200 inhibitory neurons to construct the IZH and the MIZH spike neural networks. When the external stimulus is applied to them, they can generate the action potentials, and the MIZH spike neural network perform the high firing frequency. We can see it in figure 16. The synaptic weight affects the collective behaviors of the MIZH spike neural network. When the synaptic weight is 0.05, the MIZH spike neural network is in a synchronous state. When we increase the synaptic weight to the 0.1, the MIZH spike neural network is still in a synchronous state, but it is different from the previous one. When the synaptic weight is 0.35, the MIZH spike neural network is in the synchronous state. We increase the synaptic weight to 1. The MIZH spike neural network is in another steady state. The MIZH spiking oscillatory network is formed by 9 times 9 MIZH spiking neuron models. The white grid is the resting state of the MIZH spike neural model. The color grid is the firing state of the MIZH spike neural model. To guarantee the convergence of the network, it needs 81 iterations. The simulation results show that the MIZH spiking oscillatory network can memorize and retrieve the fundamental patterns correctly and successfully. The FHN spike neural model is the typical artificial neural model. It has rich dynamic behaviors and can imitate the afferent process of a neuron. The Memristive is a non-volatile and tunable resistance device. We introduce a Memristive into the FHN spike neural model and build the MFHN spike neural model. When the external stimulus is applied to them, they can generate the action potentials. And the MFHN spike neural model performs high firing frequency. The MFHN spike neural model is very sensitive to the control parameters A, B, and C. The different parameter values affect various dynamic behaviors, the generation of action potentials, and the spiking frequency. We can see it in the figure 22. The two MFHN spike neural models coupled with a memristor. When the same external stimuli applied to it, it performs synchronous behavior in figure 24. When the different external stimuli applied to it, it performs asynchronous behaviors in figure 25. The MFHN spike neural model can effectively replicate and complete the logic functions of NOT and OR. The waveform on the right corresponds to the truth table on the left. The MFHN spike neural model can realize the half-adder and full-adder functions. The proposed MLIF, MICH, MFHN spike neural models are verified by simulating results and these applications. We notice that they can generate the action potentials and can mimic the firing process and functional mechanisms of neurons, and can reproduce the dynamic activities of neurons. Our future work includes 4 parts. Materials. We need to analyze the materials, structures, and the processes of all kinds of memristive devices. We need to explore new materials which are more suitable for the constructing the ion channels of memristive neurons. And we need to seek the fabrication technology of ion channels memristive with a low cost and high accuracy. So we need to develop a memristive channel similar to the characteristics of biology neuron ion channels. Mechanisms. We need to further understand the action potential generation mechanisms of the biological neurons. The information exchange mechanism between neurons, and explore unknown neuronal mechanisms, including regulation mechanism, synaptic mechanism, protection mechanism, stochastic resonance mechanism, networks. The research goal of the single spike neural model is to construct large-scale or ultra-large-scale novel spike neuron networks through the interconnection of spiking neural models. And we need to realize the real-time collaborative information sharing, communication, and interaction of the system network. Hardware. The hardware implementation of the spike neural model needs more intelligent information processing methods and more effective verification schemes to design spike neuron hardware circuits. And we need to consider the performance indicators such as power consumption, accuracy, running speed, and reliability. That's all about my topic. Thank you.